So for this learning module, I just wanted to do a couple more quick examples showing how you assign your unknown reactions in these rigid body equilibrium problems. So for the first example, here we have a beam. It's supported by a pin connection at A, along with a cable, which is connected both at B and E. But if one notice, it's the same cable passing over a pulley. And if we recall back to chapter 3, we know that the tension throughout the cable, or a rope in this case, is equal. So the problem states that we're supporting this 80 kilogram load, which is applied at point C. And if we were to draw a free body diagram of the beam, of course, in general, it would include this load pulling down at C. It would include the weight of the beam along with the reactions at A, B, and E. And the question is, how many unknowns would there be? Well, if you go back to the table that we introduced in the previous learning module, you'll recall that for a pin connection, there are two unknown forces: the unknown force in the horizontal direction and the unknown force in the vertical direction. And what that says is that this support structure can overcome translation in horizontal and vertical direction, but it can't overcome any rotation. In addition, we would have reaction forces at B and E. They would be directed at a known direction along the line of action of the cable, but they would be of an unknown magnitude, which is actually the same value. So the free body diagram of this would have the tension in this rope pulling up at B, the tension in this rope pulling up at an angle at point E. It would have the two unknown reactions at A, the X component and the Y component. So in total, there are actually four unknowns, and they're all forces, right? The X and Y component of the unknown reaction at A, along, I should say three. I described it correctly, but said the wrong thing. The unknown X and Y component of the reaction at A, along with the unknown magnitude of the tension, which is at B and E. So three forces is the answer there for how many unknowns. Second question here, we have a distributed load. We have this fastened securely at point A, and in addition on a roller at point B. So if you look back at your tables for this type of connection, since this connection can overcome, you can kind of imagine this is like inserted in the wall and cement is poured around it. So it has the capability to overcome translation and rotation. Versus the roller, of course, the reaction force there will just be perpendicular to the surface. It doesn't have the capability to even overcome translation along its surface. So how many unknown support reactions are there? Well, we have one here. It's just going to be the unknown magnitude perpendicular to the surface. But at A, we have three: the unknown reaction in the horizontal, vertical direction, along with the unknown couple. So three here, one there. So it will be four total, or three forces and one couple moment. So hopefully that was a nice additional example to kind of emphasize probably the most challenging part of this chapter beyond the kind of just rigidness of the math, which is how you actually assign your unknown reaction force for each particular support structure type.